we always do the laser beam alignment before shipping the machine to the customer, but in some cases we experience some sort of misalignment due to transportation or vibration of the machine while transportation, and for that you might need to check the laser beam alignment and do a minor adjustment. Usually the adjustment you need when you receive your machine, if there is some misalignment, is from this first mirror to the second mirror. So that means you need to adjust only the first mirror. So the second and the third mirror usually are just remain in the same adjustment as been done in our workshop. But if you change the laser tube for some reason, you need to adjust the laser tube height, the first and second and third mirror, and it has to be done from the beginning. So during this video, when we say the first mirror, we mean the mirror which is located at the front of the laser tube and the left top corner, and the second mirror is the mirror which is in the left side of the laser head. That's the second mirror. And the third and last mirror is the mirror located on the top of the laser head. Then after that it goes to the lens, which is at the bottom side of the lens tube holder. The main objective of laser beam alignment is to adjust the laser beam in such a way that enters the laser head entrance hole always at the same position and at the center of this hole, no matter where the position of the laser head. For adjusting the laser tube height, stick a piece of masking tape on the opposite side of the Allen screw retaining screws. Mark the existing position of the laser tube. Then loosen the retainer screws. Then use the adjustment knob on the bottom side, and by turning the adjustment knob counterclockwise, you'll take the laser tube down, and by turning this adjustment knob clockwise, you will take the laser tube up. Then after you finished your adjustment, just tighten the retainer Allen screws. For adjusting the laser beam alignment for the first and second mirror, there are 3 adjustment screws. You need to loosen the retainer ring screws first. Then by turning the bottom left screw clockwise, you'll move the laser beam from left to right. And by turning the right top screw clockwise, you'll move the laser beam from up to down. And by turning both right top and bottom screws clockwise, you'll move the laser beam from right to left. Then after you finished your alignment, you need to just tighten in these ring screw retainers. The first thing we need to do before starting the laser alignment is to adjust the laser test time period and power. And for that you need to just go press menu, and in the menu you can go to laser set, press enter, and here as you can see is a laser time set and laser power set. For 80 watt machines we usually use 40 milliseconds and 100% power. So the way which we change this is we can use the left and right arrow keys and go through digits, and once we are on the digit we want to change, we just use up and down arrow key to increase or decrease the value, and then after we finish we press enter, and that's it. In this way, when we press the laser button, it just releases the laser for 40 milliseconds with 100% power, and it will prevent from overburning the masking tape we use for locating the laser spots, and it will prevent the staining the mirrors with overburning. To start the laser beam alignment process, you're going to need a masking tape with about like 1.5 inch width. So what we're going to do, we just remove 2 pieces of the masking tape, and we just stick them on top of each other. First step would be the alignment of the first mirror. What we do, we just place the double masking tape, put it on the second mirror, and then we jog the head on the back and press laser button. We leave a spot on the masking tape, then we jog all the way to the front, and then while we're watching the first spot, we just use the laser button and create another spot on the masking tape. So the second spot should match on the first spot, and based on the location of the second spot, if it is not matching on the first spot, you have to align the first mirror in a way that second spot matches on the first spot. And for the marking on the second mirror, it doesn't have to be on the center of the mirror, as long as it just sits within the area of the mirror, it would be sufficient. For adjusting the second mirror alignment, we use the same double masking tape, or we can use the centering tool, which is provided in the toolbox, and slide a piece of masking tape inside the slot like that, or a piece of thick business card and put it on the top of the entrance hole on the laser head. But I personally prefer the same masking tape, just put it directly on the hole in a way that we can recognize the hole pattern. Then we jog the laser head to almost center in a y-axis, and to the left side on the x-axis, and use the laser button and press once and leave a spot on the masking tape, then jog the laser head all the way back with the laser head all the way back, or all the way to the right position. We use the same laser button and press it once, and the second spot also should match on top of the first one. If the second spot is not matched on the first spot, then we adjust the second mirror with adjustment knobs in a way that match the second spot on the first one, and we can just repeat this process while we just adjusting the second mirror alignment until the second spot match on the first spot. In some cases, after adjusting the first and second mirror, so the spots on the laser head entrance hole are matching on each other. That means the spots and all over the table, including the right bottom corner and left top corner, are matching on each other on this entrance hole, but they are not in the center of entrance hole. So in this case, there are some other adjustments which are required to make this spot to the center. In the case of the spot is to the right side or to the left side of the center, we could use to adjust two Allen screws which holding the second mirror to the long bar, to the x-axis long bar, and move it with a very gentle movement in a way that we keep the angle same like a existing angle, and then compensate the left or right mispositioning of the spot on the entrance hole. In the case that the spot is in the upside or downside of the center, then we have to adjust this mispositioning by lowering or raising the laser tube. So in the case of the spot on the left or right side of the center, if the spot is at the right side, a simpler solution is to move all these adjustment screws a little bit forward at the same time, so it could move the second mirror a little bit further, so this could compensate the mispositioning and move the laser spot to the left. But if it is on the left side of the center, then the only solution would be to loosen these two Allen screws, which could move the second mirror to the right, and then compensate and bring and move the laser spot size to the right. But moving this bracket, it's very sensitive, and if the angle changes while you're moving just a little bit, even 1 or 2 degrees, it could cause a large deviation of the laser beam when the laser head goes all the way far from the second mirror. So you need to be more careful when you move the second mirror by loosening these 2 Allen screws. In the case we have here, the laser spot is the left side of the center. So in order to compensate that, we're gonna move the second mirror to the right side. So what I would do, I would mark the existing position of the bracket by a sharp tool, and then I loosen these Allen screws and slide the bracket almost 1 millimeter here. So the marking I made, it just helps me to move the bracket parallel to the existing position. So I would move it with almost same positioning, angle position. And I tighten one screw and just keep the other screw a little bit looser for final adjustment. Then I would use the same double masking tape. I put it in the hole, and I can see the hole pattern here. I just move the head to the left side, and then leave one spot, and I can see that the spot is already moved to the right, and then in the second position, in the far right position, I just use a laser button again, and as you can see, it just already moved to the right. So in some cases, if the angle is too much distorted, you can't see the second spot. So to find out the position of the second spot, it's better to use a bigger, larger piece of material. Suppose I could use a piece of material like that and just leave a spot and see where almost the position, and then I adjust the angle with moving the whole second mirror assembly in a way that the second spot comes inside the whole pattern. And then for fine adjustment, I could use those mirror adjusting screws. I just readjust the whole second mirror assembly, and then I just leave another spot, and if you can see, it's just moved all very much to the left. So I make a little bit more adjustment, and it's almost in the center. So I just tighten the Allen screw and I'll proceed with my fine adjustment with those adjustment screws which moves only the mirror. So I did the fine adjustment with adjustment screws after tightening those Allen screws for the bracket, and I just leave one spot on the far left, and see, this is the first spot, which looks almost in the center of the hole. And then while I'm watching the first spot, I'll notice where would be the second spot, and as you can see, it just matches on the first one. So as we mentioned before, if it wasn't matching, we just readjust it with the screws to move the second spot on top of the first spot. The last stage of the laser beam alignment would be the adjustment of the third and last mirror, which is on the top of the laser head. So for that, we need to remove the autofocus in the red dot assembly first. For that, we just make enough space in the Z-axis and slide up the assembly. The detailed instructions are in the operation manual or other videos concerning the disassembling of the laser head. And then we use the lens tube assembly with the lens, slide it in only, and then we use a piece of like a 1/4 inch MDF or a very flat or solid cardboard and put it underneath the laser head, and then we can adjust the table height to the focal point. So it's better to just leave the laser tube a little bit outside to just have more space while we want to remove it. And then we adjust the height to the focal point, and by pressing the laser button once, we leave one laser spot on the cardboard. Then without moving the cardboard or MDF sheet, we can remove the lens tube assembly carefully, and then use the same laser test button and leave another spot, which is a larger spot because it's without the lens. And the main objective is to align the third mirror in a way that match the second larger spot almost on top of the first small spot, and adjusting the third mirror has the same principle as the first and second. We just loosen the retaining ring screws, and by turning the top left adjustment screw clockwise, we can move the laser beam from top to bottom and vice versa. And by turning the right bottom screw clockwise, we can move the laser beam from left to right and vice versa. And by turning both right top and bottom screws clockwise at the same with the same amount, we can move the laser beam from bottom to top. Here you can see 3 different tests that we did for the third and last mirror. And the first right, see the small spot, which you can see it here, it's almost on the right top corner of the big spot. So with more adjustment, we just did it a little bit closer to the center of bigger spot, and with the final adjustment, as you can see, the small spot which we did it with the lens, it's almost in the center of the big spot which we did it without lens. So again, we just move the bigger spot by adjusting the alignment screws, and move it on this to the center in a way that the small spot just goes in at the center of the bigger spot. Then after making sure that this is just matching on top of each other, we just tighten the retaining screws. And put back the autofocus and red dot assembly. And that's it for the laser beam alignment.